Greetings, fellow knowledge seekers. Ernis, here, ready to plunge into the wild, wonderful world of cutting-edge research. Today's adventure, we're cracking open a fascinating paper titled AgentFrontier, Expanding the Capability Frontier of LLM Agents with ZPD. Guided Data Synthesis. Now, before you glaze over, let's translate that into something a bit more digestible. Imagine a cosmic playground where AI agents are learning new tricks. This paper is about pushing those AI agents to their absolute limits, but in a way that mimics how we learn. The central idea? The zone of proximal development, or ZPD. Think of it like this. You're trying to learn to ride a unicycle. Impossible on your own, right? But with someone spotting you, giving you little nudges and tips, you gradually get it. That's your ZPD. The sweet spot between what you can and can't do with a little help. This paper, by Chen et al., takes that concept and applies it to large language models, or LLMs. These are the brains behind chatbots and AI assistants. The authors argue that the key to making these LLMs smarter isn't just throwing more data at them, it's about carefully crafting training data that sits right on the edge of their current abilities. So, how do they do it? Buckle up, because we're about to enter a memory palace of algorithms and agentic refinement. Imagine a grand library, each room filled with a different stage of the AgentFrontier Engine. In the first room, we have seed question generation. Think of this as the spark that ignites the learning process. The engine starts with a massive collection of documents, over 1 million. Then, it uses an LLM to find groups of thematically related chunks. It's like finding constellations in the night sky. Finally, it crafts initial questions designed to require knowledge fusion across those chunks. Next, we step into the escalating complexity chamber. Here, an LLM agent with access to tools like web search and code execution acts as a refinement agent. It takes those initial questions and iteratively makes them harder. It's like a cosmic game of one-upmanship, where the AI is constantly pushing itself to new heights. The paper mentions 4 ways this agent makes questions harder: knowledge expansion, conceptual abstraction, factual grounding, and computational formulation. That sounds absolutely mind-blowing. Let me take you through a mind palace I've constructed to help us understand this. Picture a cosmic treehouse of knowledge. In the first branch, we find knowledge expansion. Here, the agent actively seeks information from external sources, broadening the question's informational scope. It's like adding layers of context to a cosmic painting. In the second branch, we encounter conceptual abstraction. This involves conducting an in-depth analysis of the core concepts, abstracting higher-level principles or identifying subtle relationships. It's like zooming out to see the larger patterns in the universe. The third branch is factual grounding. This performs multi-source cross-validation to enhance the factual accuracy and depth of the content. It's like anchoring our knowledge to solid ground. And finally, in the fourth branch, there's computational formulation. This leverages Python execution to create questions that require quantitative calculation or logical simulation. It's like adding a layer of mathematical precision to our understanding. Fine, yeah, I guess. Finally, we arrive at the ZPD-based filtering and calibration room. Here, the engine uses a clever trick to ensure the training data is just right. It uses 2 LLMs. A less knowledgeable peer, LKP, and a more knowledgeable other, MKO. If the LKP can answer the question, it's deemed too easy. If the MKO can't answer it, it's too hard. Only the questions that the MKO can answer, but the LKP can't, are kept for training. It's like finding the perfect balance point on a cosmic scale. This ensures that the training data is always challenging, but not impossible, pushing the LLM to continuously improve. But wait, there's more. The authors didn't just create this engine, they also created a benchmark called the ZPD exam to evaluate LLM agents on these frontier tasks. It's like a cosmic report card, showing how well the agents are learning. The results? They trained a model called AgentFrontier on their synthesized data, and it achieved state-of-the-art results on demanding benchmarks, even surpassing some leading proprietary agents. Now, I want you to join me in visualizing something remarkable. Imagine you're standing at the edge of a vast, unexplored galaxy. Each star represents a piece of knowledge, and the spaces between them represent the unknown. As we're uncovering this together, what do you see? What patterns emerge as you observe this landscape? This is precisely what the researchers uncovered when they built AgentFrontier. So, what's the big picture here? This paper is a big deal because it shows us a new way to train AI agents, one that's inspired by how we learn. By carefully crafting training data that sits right on the edge of their abilities, we can push these agents to new heights of reasoning and problem solving. The implications are huge. Think about AI assistants that can truly understand and help us with complex tasks. Or scientific discovery tools that can accelerate research in every field. That's the promise of AgentFrontier. As we conclude this cosmic journey, remember that the quest for knowledge is never truly over. The AgentFrontier is constantly expanding, and there's always more to explore. So, go forth, dear listeners, and embrace the challenge. Delve into the depths of this paper, ponder its implications, and let your curiosity be your guide. The universe of knowledge awaits. Until next time, keep exploring.